Lastly, I want to showcase how we can use integration to find the volume of a 3D object, in this case of a sphere. But before we do, I need to go over two rules. Firstly is the constant rule, which states that regardless of whether the constant is inside or outside the integral, the final result will be the same. And the sum rule, which states that the integral of a sum is equal to the sum of two integrals. Let's begin to find the area. We can visualize this with the diagram of a circle on a graph, which goes from negative r to positive r, and that the radius equals the root of y squared plus x squared. This is at point 0, so both sides are equal in length. And in the diagram, there is a cross-section that represents a circle slice, with the radius of that equaling y of the diagram. So we can basically imagine the sphere as the sum of infinitely thin slices of circles with radius y. Firstly, we need to look at the equation for a circle on a graph, which states that r squared equals x squared plus y squared. We can rearrange this to get y squared equals r squared, take away x squared. So we are basically going to treat y as if it were r, or the radius of the inner circle cross-section, which means that the circle area would be equal to pi y squared, which equals pi times r squared take away x squared. We now insert this equation into the integral, as it acts like a function itself when we look at the diagram as a whole. We can then simplify this into 2 pi times the integral from 0 to r of r squared take away x squared times dx. We do this to eliminate one of the antiderivatives, because an antiderivative at 0 is 0. We will now find the integrand of the equation, which is 2 pi multiplied by xr squared take away x cubed over 3. Since we use the reverse power rule and r is a constant, so we just add or multiply it by x. We then substitute r for x, which gives us 2 pi times r cubed take away r cubed over 3. This is because we only need to deal with the antiderivative when x equals r. Then this simplifies into 2 pi times 2r cubed over 3, which then simplifies into 4 pi r cubed all over 3, which actually equals the equation for the volume of a sphere. This is the end of my presentation on the basics of calculus. I hope you learned something. Thank you for watching, and goodbye.